This is number 6 on the review sheet for the honors intro to force test. I have 3 dogs. They pull a 300-kilogram sled to the west. The 3 dogs, Logan pulls with 20 newtons, Kira pulls with 40 newtons, Brody pulls with 30 newtons. If the force of friction between the sled and the snow is 10 newtons, what is the acceleration of the sled? So I need to draw a free body diagram. I don't need the weight in this case because it is not a vertical problem. I do know that the 300 kilograms, that is my mass. I don't need my weight. I've got my free body diagram. And I've got my 3 dogs pulling over here. And I'm just going to label those FB for Brody. He's pulling with 30. FK for Kira. She's pulling with 40. And FL for Logan, who's pulling with 20. And then I also have the force of friction, which is opposing it, which is equal to 10. So I've got all 4 forces. For my free body diagram, everything's filled out. I don't need my weight and I have my mass. And so I'm going to do the sum of the forces equals m times a. In this case, I now have 4 forces. So over here, I will have minus Kira's force, minus Brody's force, minus Logan's force, plus the force of friction. So this is all about the direction. And then from here, you just plug in your numbers. I've got 40 minus 40 for Kira, minus 30 for Brody, minus 20 for Logan, plus force of friction, which is 10, 300A. So all I did here was plugged in these values from my free body diagram. I end up with, I'll add all these together, and I get negative 80 is equal to 300A, and that's the net force. It's just another way to say net force. And then I divide both sides by 300. I find my acceleration is negative 0.2667 meters per second squared, or A equals 0.2667 meters per second squared west.